Lecture on Measuring Instruments. Introduction. Welcome, students. Today, we are going to delve into the fascinating world of precision measurements with a tool that has been a cornerstone of metrology for centuries, the Vernier Caliper. The Vernier Caliper is an essential instrument in science, engineering, and various industries, enabling us to make highly accurate measurements of length, diameter, and depth with remarkable precision. During this lecture, we will explore the construction, working principle, and usage of the Vernier Caliper. 1. What is a Vernier Caliper? The Vernier Caliper is a mechanical measuring instrument used to measure the dimensions of objects with exceptional accuracy. It consists of a main scale and a sliding Vernier scale, which provides finer readings beyond the resolution of the main scale. This combination of scales allows the Vernier Caliper to achieve readings with a high degree of precision, often up to 0.02 millimeters or even better. 2. Construction of Vernier Caliper. Let's look at the construction of a Vernier Caliper. A. Main scale. The main scale is the larger fixed scale running along the length of the caliper. It typically measures in centimeters or inches, and each division represents one unit, e.g., 1 millimeter or 1/16 inch. B. Vernier scale. The Vernier scale is a smaller movable scale that slides along the main scale. It has a slightly different length from the main scale, but it covers the same distance. The divisions on the Vernier scale are also slightly different from those on the main scale. C. Jaws. The caliper has two sets of jaws, the upper and lower jaws. The upper jaw is fixed and is located at one end of the main scale, while the lower jaw is movable and attached to the Vernier scale. These jaws are used to measure external and internal dimensions of objects, respectively. D. Depth rod. Some Vernier calipers also have a depth rod, which is a slender, extendable rod attached to the back of the lower jaw. It allows measurements of depths in narrow holes and slots. 3. Working principle. The Vernier caliper operates based on the Vernier principle, which is named after its inventor, Pierre Vernier, a French mathematician and instrument maker who developed it in 1631. When measuring an object, follow these steps. Close the jaws of the caliper and ensure it is clean and free from dust or debris. Place the object between the jaws, making sure it is firmly seated. Slowly open the jaws until they grip the object. Read the main scale measurement that lines up with the zero mark of the Vernier scale, left end of the Vernier scale. This is the whole number part of the measurement. Find the Vernier scale division that best aligns with any division on the main scale. This will be the Vernier reading. Add the Vernier reading to the whole number part obtained from the main scale to get the final measurement. 4. Using the Vernier caliper. The Vernier caliper is highly versatile and can measure various dimensions such as length, diameter, and depth. Some common types of measurements include: A. Outside measurements. For measuring the external dimensions of objects, use the upper jaws of the caliper. B. Inside measurements. For measuring the internal dimensions of objects, e.g., the diameter of a hole, use the lower jaws. The depth rod can be used to measure the depth of the hole as well. C. Depth measurements. To measure the depth of a groove or the depth of a hole, use the depth rod. 5. Accuracy and sources of error. Vernier calipers are capable of providing highly accurate measurements, often with resolutions as small as 0.02 millimeters. However, several factors can introduce errors in measurements, such as parallax error, when the eye is not perpendicular to the scales, dirt or damage to the scales, and improper handling of the caliper. Conclusion. The Vernier caliper is an invaluable tool in the world of precision measurements. Its ability to provide accurate readings has made it a staple in scientific, engineering, and industrial applications. By understanding its construction, working principle, and proper usage, you can ensure that you make precise measurements and contribute to the advancement of various fields of knowledge. Keep practicing, and always strive for accuracy in your measurements. Happy measuring!